taking up the homework. So with question number 4 here specifically, this is the question that involves using standard deviation. So the first step we're going to do is we're going to copy and paste this entire table, and there's some more of it down here, into a new spreadsheet. So Control C or Command C if you have a Mac, and let's pop over to our Brave browser and then simply paste it into our spreadsheet. Now I'm going to be a bit persnickety here, so I'm going to undo that and I'm going to put the title data. All right. And I'm going to increase the font size so it's a little bit easier to read. Okay, so we have all our data here. I'm going to zoom out a bit so you can see all the data points over here. And I'm going to do one other thing. I'm going to move it one column over. And then down here, let's call this average. So the first thing, how about average? There we go. So again, we're going to calculate the average. So equals average. Oh, very convenient. And let's just scroll up. Yep, that works out well. And then we hit enter. Boom. All right, so the next thing we're going to do, we're going to manually do our standard deviation, and then we're going to compare it to the actual value of the standard deviation. So again, first thing, we have to calculate the deviations. So that is going to be equals our first cell minus, and let's scroll down to where our average is located. Okay, good. Now, of course, we have to put an anchor in front of the 27, and let's see what we got going on here. All right, yeah, so that's good. We also want absolute value. So we're going to put that abs function in front, and then let's scroll on down. Okay, next, our deviation squared. So that is equal to this squared, and I'll do the autofill manually. Now, in this particular case, it's rounding off quite a bit. So what we can do is we can actually have it expressed in scientific notation if we wanted. So if you go here under scientific, it'll actually put it in scientific notation. Now, round it off to 2 sig figs, but whatever, it's fine. All right, so the next step after that. So we found the square of the deviations. Next step, of course, is to find the sum. So equals sum, and let's see, it looks like, it's very good. Predicted exactly what we wanted, but I guess we can leave it in scientific notation. Okay, so then let's determine the count less 1. So we'll go equals count, and then highlight all these cells, and then of course edit it so that it is count minus 1. All right, there we go. And then now we can actually probably do a couple of steps in one go. So now what I'm going to do is I'm going to find the square root of this number divided by this number here. And that should be our standard deviation. Now let's just check it against the actual standard deviation calculation. So equals stdev, and on the original data, so highlight it all. Don't include your average. I've made that mistake before. Hit enter. Look at that. We did it right. Awesome. Okay, so now the next thing is we have to do the upper lower limit business. So we'll put those, I guess we'll put it right here. It doesn't really matter where you put it really. So that's just equal to our average plus our standard deviation. And this one is going to equal our average minus our standard deviation. Okay, so the address of this cell is F30 and F31. And you know what? I don't like the way I did that. It's less logical. I'm going to do this. I'm going to grab, let's try that again. Highlight these 2 cells. Wait till I see a hand. I'm going to move that over here. And then what I'm going to do is I'm actually just changing their positions, because it probably makes sense to have the lower first, then the upper. So that way F30 is the lower and F31 is the upper. So let's do our range test. Range test. There we go. Okay, so to do the range test, we have to see if this value here is within range. So we're going to start off with our AND condition. So that is AND. So this has to be greater than the lower limit. And B2, we'll just do it manually this time, must be less than or equal to the upper limit. Of course, we have to have add our dollar signs in there. And maybe I should zoom in a bit. And error. Let's see what we did wrong. Oh, I'm a goof. There you go. That should work. Okay. Yeah, that should be a little bit easier to read. Okay, so there's the AND test. So now what we're going to do is we're going to cut that. And then we're going to go if bracket. Then we'll paste our test. If that is true, now we put in our comma. We report a 1. If it's false, we report a 0. Close bracket. And there we go. So now we can just fill down all the way. And there we have it. Final step equals average. And it's predicting what we want to do. And then we hit the percent symbol. Perfect. And look at that. We have a normal distribution. Very exciting stuff. Okay. So again, a little recap, and let's zoom in here. So to calculate the average, the function is equals average B2 colon B26. Now note that the average is located at B27. So now to calculate our deviation, that is going to be our data point B2 minus B27. And if we scroll down, you can see the average is highlighted in purple, and the dollar sign ensures that the 27 doesn't increment when we do fill down. All right, so we can just hit escape there. And then of course, when we check the dev squared, all it is our deviation, which is in C2. And we use the little hat symbol, which is shift 6. And that gives us our squared value. And of course, then we use the blue square to fill down. And that's how we got all these values. To calculate the sum, it was sum from D2 to D26. So it's the same numerical range, just at a different column, column D. Down over here, I calculated the count less 1. So I did the count of D2 to D26 less 1. And then, of course, finally, the standard deviation is going to be the square root of our sum divided by the count less 1. But more importantly, stdev bypasses all this extra work. So in any other instance, you would just jump straight to here and we wouldn't bother with any of this, this extra stuff. And finally, let's just take a look at the range test. And that one is the one that requires the most little bit of logic here. So we established our upper and lower limits. So our lower limit, again, is just equal to our average minus the standard deviation. And the upper limit is equal to the average plus the standard deviation. So our lower limit is located at F30. Our upper limit is located at F31. So when we scroll up here, double click on this. So let's take a look at the AND condition. So for this to be satisfied, B2 has to be greater or equal to the lower condition, which is at $30. And again, the dollar sign is to prevent the 30 from incrementing. It stays locked at 30. Our upper limit is at $F31, and the dollar sign just locks it in at 31. And the if conditional is that if this AND condition produces a true value, it reports a 1. If it produces a false value, it scores it as a 0. And then these are the results. And the final step was to take the average of this column, and the average of that column gives us our percent within the range. So in this case, we get 68% within range, which is precisely what we expected for a normal distribution. So this would represent a perfect data set, because we see that we have generated a normal distribution out of it. Generally speaking, you can get close to 68%, but there's always going to be some noise that'll throw it off. But in this homework question, I specifically picked a quote unquote perfect data set to make that happen. So there you have it.